Let us start this lecture with a thought process. Belief of being a divine person is the ignition switch for realizing your potential lying dormant. In the last lecture, we basically looked at the gaseous fuel and its properties and heating value of the liquid fuels and also various kinds of liquid fuels and oxidizer. And today we will be looking at properties of the liquid fuels. If you look at the very important property is the specific gravity, because it is fuel, liquid fuel is being used for in transportation. So, therefore, the specific gravity plays a very important role, and which is defined as the ratio of mass of density of fuel to the mass density of water at the same temperature, right. Of course, the people use the standard temperature, right, and Sg is basically rho fuel divided by rho water, and reference temperature is being taken as basically for fuel and water is 298.8 Kelvin. Okay. And of course, the American Petroleum Institute, he has developed a scale by which you can use, and that is known as API scale. API Sg will be 141.5 divided by Sg minus 131.4. Of course, they use it and these are all some constant values, and whereas why not we can use this Sg, the question might be coming to your mind, right. Why not use Sg, why should I use API Sg, right. And they have devised this, they claim that it can be used for basically finding out a relationship between the higher heating value and API Sg. So, they have come up with a formula, right, for the gasoline HHV is equal to LHV plus 93 API Sg minus 10, and the unit is basically kilojoule per kg, right. And for kerosene they have come with the similar formula, right, and the constants are same. It may be valid for these constants may change for various fuel, keep in mind, and these are all semi empirical, you may use, you may not use, otherwise you can get the Sg, you can relate your find out your own way of doing that, right. It is not necessary to use this one, but however it will be handy. Earlier days people were designing, so they will be very easily do that to calculate and other things, but today it is a different thing. And some of you are told that basically self ignition temperature or auto ignition temperature, it is the lowest temperature required to make the combustion self sustained without any external head, right. Suppose I will remove this ignition source, but it will be going on, right. If the temperature attained by the fuel, if it is a low, let us say auto ignition temperature low, that means it is very easy to ignite, because I will give very little amount of energy so that it will go to that temperature, and after that is self sustained, right. Even if I withdraw the ignition source, then still it will be combustion will be taking place. Lower the self ignition temperature, auto ignition, better it will be. However, it will be having problem. What is the problem? Hazardous, because if by mistake something is happening, then all fuel will be getting burnt or coming in contact with the oxygen. So, therefore, it will be dangerous. So, there is another property which is known as flash point. Flash point is basically minimum temperature at which liquid fuel will produce sufficient vapors to form a flammable mixture with air. I think you are talking about this point, like where vaporization will be there, right, some amount of vapor, and this is known as flash point. Flash point is occurring, that does not mean that it will be self sustained combustion, okay. It may have a flash, some kind of a little fire, and after that it may extinguish, right. So, that means why it is required? Because it indicates the maximum temperature at which liquid fuel can be stored without any fire hazard, right. Because if you go beyond this, then only the flash will occur, then only fire hazard will occur. Otherwise, if below you are storing, then you are safe. So, for storage it is very important to take aware about what is the flash point of the fuel, right. So, there is another temperature which is known as a fire point, and fire point is the minimum temperature at which liquid fuel produces sufficient vapors to form a flame mixture with air that will continuously support the combustion, right. But the flash point will just have a flash, it may not sustain, or rather it will not sustain, but in this case flame will sustain, right. That is the difference between flash point and fire point. As I told that it will be after just flashing the flame will be continuing, but in case of flash point there will be flash, it may stop or it may not, right. There is also another point which is known as, another property is known as smoke point. It is basically a measure the tendency of liquid fuel to produce soot, right. Okay. There is also similar things is being utilized for the gaseous fuel as well, right. There will be smoke point where it will started smoking, right. And smoke must be avoided. Okay. There is a cloud point, the temperature at which wax crystal starts forming from a liquid fuel when it is cooled. Suppose you cool the things, it became wax being formed, and wax being formed means it will be very difficult to use as a fuel, particularly in the cold country or cold region like Himalayan region, other thing in winter. If the cloud point or the temperature reaches, then it is very difficult to start the engine, right. So, therefore, it will be better that you should be avoided, right. So, these things are to be there from for the liquid fuels. Let us look at typical values what I am trying to give here, that is the specific gravity. Automotive gasoline, there might be different gasoline like like aviation gasoline will be different than the automotive gasoline, right. And it values is 0.07 to 0.78, and diesel of course 0.85. that means what? 0.85 means what? With respect to water, this density, okay. If it is 1000 you take, that means it will be 850 kg per meter cube, right. And methanol is 0.796, you can say around 0.8, kerosene is 0.82. Of course, this is like ATF. ATF, what is the meaning? Aviation turbine fuel. This is JP8, there will be several like JP10, there are various kinds of fuel are being used, particularly aerospace people, they will be knowing. This is like kinematic viscosity is very important, because if the viscosity is very high, then what will happen? It is difficult to atomize, right. And then if it is not atomized, then you cannot really burn properly, you cannot burn it properly. So, boiling point range also very important, and I have already discussed about flash point. If you look at the lowest is the gasoline, and auto ignition temperature, if you look at highest is the methanol, right, whereas the gasoline is next one and the kerosene is lowest, a little dangerous like use kerosene as among all these fuel, right. And stoichiometric air fuel mass, if you look at most of them around 15, okay, and this is 6.43, and this is a heat of vaporization. Generally we use the lower heating value for our calculation purposes, okay, and that is the lowest one. All other things are around 40 to 45 megajoule per kg, okay. This is a very large amount of heat. Okay. So, let us look at solid fuel and oxidizer. There are various kinds of fuel like wood, coal, charcoal, soft coke, biomass, animal dung, I mean basically cow dung we use, and propellants, right. And if you look at constituents of solid fuel, what it would be? Of course, carbon will be there, right, hydrogen will be there, that is the thing. And what else other thing? There will be several other things, carbon will be there, hydrogen will be there, as will be there, nitrogen will be there, oxygen will be there, sulfur and water content will be there, right. But see, it is very difficult how to put a chemical formula, like it is very difficult. But however, I have given a simple model, not I have given, it is given by others, I am just quoting, they have said that CHNOM, these are the values, like 1.78, 0.56, sawdust 1.65, 0.69, these are all semi empirical things, right. And keep in mind that there is some complex formulas will be there also, chemical this thing, where the nitrogen is coming into pictures and sulfur is also coming into picture. This is some, but I have taken the simplest one. So types of solid fuels, if you look at biomass, the biomass several of them, wood, sawdust, rice husk, rice straw, wheat straw, and several of them, right. Anything whatever, even like things you can burn, and it is used for domestic or engine application, because you can produce the producer gas out of this biomass, and coke, coal, charcoal, you can use same application. The special fuel like nitrocellulose, nitroglycerin is basically oxidizer, and STPB, hydroxyl terminated polybutadiene, and CTPB. CTPB means carboxy terminated polybutadiene. These are used by ISRO profusely, but there will be several other fuels in propellants, and ammonium perchlorate as an oxidizer, ammonium nitrate, nitrogen tetroxide, these are all oxidizers, right, can be used, and it is used for solid propellant rocket engine, hybrid propellant rocket engines and other things, which we will be not dealing with, but for the completeness sake I have just included here. Let us look at basically oxygen, water and content of certain solid fuels. Basically moisture will be free and bounded. Free means if you just vaporize it will go away, and will affect, because fuel moisture, why we are concerned about moisture of solid fuel, because it will affect the rate of combustion and overall efficiency. First of all, you have to supply amount of energy so that it will vaporize, right. Beside this, if it is there, then it will hamper the combustion to take place, right, and as the inorganic materials which remain as right. Beside this, if it is there, then it will hamper the combustion to take place, right, and as the inorganic materials which remain as a residue even after complete combustion takes place. So therefore this cannot be burnt, it will be just you are carrying a piggy back under in your shoulder, like as a fuel. So therefore it is wastage. As content also affect the performance of combustor, because it will be what you call on the layers, it will be like acting like insulations and then absorbing the heat, therefore combustion efficiency. As content of coal causes fouling of the boilers, and when it will emit, it will causing a lot of problems. And if you look at the given some of the fuel like wood, peat, lignite coal, bituminous coal, anthracite coal, if you look at these are the constituents which are are there in the range. The oxygen generally, wood will be, lot of things will be there, dry ash and ash free, like, whereas as moisture is much more in the wood, right, as compared to anthracite coal, and ash is very less, right, here. But whereas these coals is Indian coals, will be having something 20 to 40% of ash. That is the biggest challenge, right, for us to handle, how to handle those kind of coal, which we are having a very good, very vast reservoir we are having. So characterization of solid fuels, if you look at, there are two ways of looking at. One is proximate analysis, that is used to determine moisture content, volatile metal, fixed carbons and ash content in the solid fuel, like, because this moisture content is very important. You have to find out what is the volatile content. Why you look at volatile content? Because that will help to ignite, because it will be gaseous fast, and fixed carbon, which will give a sustainable combustion, and ash content, of course, it should be minimized, so that hampers the combustion. And we need to determine water content. Few grams of fuel is heated around 378 Kelvin till it attains constant weight. See, this is generally a procedure. standard what is being used to analyze this thing. And volatile matter can be determined provided if it is heated, the the sample is heated at 1200 Kelvin for certain period of time. So, these are to be done so that you will find out ultimate analysis. Basically various methods are used, like because you need to determine the major elements, right, what are the things is having compositions, and for that you will have to use chemical methods for getting the nitrogen content, and sulfur method is evaluated by the precipitation methods, right, and of course calorific value can be determined by the bump calorimeter. See, what I am trying to give you basically a general view how you can do, because these are the important things to be done, particularly know the constituents of the solid fuels, so that you can come up with a empirical formula, as I told CHO, like M and N as a coefficient I have put it, or so that you can do some calculations and understand what is happening. That is one objective. Other objective is to basically look at what it contains, So, various combustion modes will be there, right, because now we are talked about the fuel. Now we should understand what kind of combustion will be taking place, right. So, if you look at the combustion can be broadly divided into flame mode and flameless mode, because flame is the genesis of combustion, okay. And the flame mode is basically premix flame. One combustion, there is another mode is the diffusion flame, right, and there is another mode which is partially premix flame, right. If you look at premix means where fuel and oxidizer are mixed before the combustion takes place, right. The example is Bunsen burner, LPG stove and other things, right. And whereas the diffusion flame is like where the fuel and oxidizer will be mixed on the surface of the combustion or on the surface of the flame or during the combustion, right. Now, and partial premix, it is in between. If you look at premix is basically what? It will be premix means it is love marriage, okay. And diffusion flame means basically arranged marriage, where you do not know each other, you will marry. Partial premix, love and arrange together, that is the combustion what you will be talking about, right. Are you getting? So, now which is good, which is bad, which is ugly is a matter of debate and discussion. As you go along we will see, particularly you remember this thing corollary, and when I will get into premix flame and then diffusion flame we will discuss, okay. And again based on the flow we can divide into two categories, one is laminar flame and turbulent flame, right. And if you look at flameless mode is a smoldering combustion. Smoldering combustion, you know what is that? Any of you take cigarette, smoking, right? Smoking you have seen, na? Is there any flame? But this is smoldering is occurring, right? Even the carbon, when you look at, there is no flame as such, carbon is burning, right? Then it will be glowing and then moving, right? So, that is smoldering. That nowadays it is not the smoldering is the flameless combustion, there is a combustion coming off is flameless, we will do it artificially, right, so that there will not be any flame. I had done some work on that earlier, and that is a new technology which is coming up, new way of doing the combustion, right. So, if you look at the environment, pollution is very important, because combustion of any fuel produces certain amount of smoke, ash, soot and other harmful gases, right. And major pollutants generated during combustion What are those? Basically carbon monoxide, carbon dioxide, nitric oxide, nitrous oxide, sulfur dioxide, unburnt hydrocarbon, right? These are the and others, right? Maybe ash, then smoke, then soot particles, right? All those things will be coming. But those are causing a lot of problem. And why is this coming? Particularly carbon monoxide and unburnt hydrocarbon, these are basically due to incomplete combustion, right? And it can be minimized by enhancing the residence time of the fuel and oxidizer mixture in the combustor, or you can provide more amount of oxygen so that, or oxidizer rather, so that combustion can take place to the full extent, right. And because of these things there is a lot of concern across the globe, right, and people are saying, because we are all using a lot of combustion systems for our transportation, for our food, for our like other activities producing electricity, then emission is coming. Therefore, across the globe people are trying to make the emission standard stringent day by day. For example, 2000, this is a BS Bharat standard 1 nationwide 2000, it was a very low like very higher values like a CO and CO2, all those things numbers are there. But in 2004 the people started using Euro 4 and China 1 and China 3 and Bharat standard 2, right. And 2010 we are saying nationwide, right, we will be doing, and of course 2015 the Bharat standard 4 in the major cities. What I would suggest, I am not put those numbers, what are the values, because it will be very vast. For diesel engine it will be different, for petroleum engine different, for the what you call buses will be different. So, the numbers are different, okay, they have given. So, therefore, I thought due to paucity of time I will not discuss. But what I am trying to draw your attention is that look at it is becoming more stringent and stringent, and then people are trying to devise this so that they will regulate, right. But now that means technology has to come up, otherwise we will be in trouble. What is happening now? They are developing technology, they are saying you buy us and we become pauper. Are you getting? So, therefore, we need to develop our technology, understanding the combustion and utilizing, so that we need not to depend on them. More and more we are depending on them because they are framing the rule and they are saying you will have to do it, otherwise you will be in trouble, they will twist arms, right. And let me tell you that emission by sources, this 2000, like energy emission means industry, power, transport and building, right, these are energy related this thing. But other resources will be waste, agriculture, land use, right, land use and agriculture major contributor in this, wastage is very less, right. Means land use means basically deforestation kind of thing, deforestation is increasing. That means our main concern is here combustion, energy emissions, where combustion plays a very important role, and that has to be looked at, otherwise we are in deep trouble. It is not that you will be solving this problem by the technology, you cannot. Of course, technology is required, but you need to also minimize the utilization of energy, because India is a populous country, right. We cannot look at the model what Western people, they say that if the energy consumption per capita is higher means you are developed. I say that we will define other way around, if energy consumption is the lowest we are developed, right. We should go other way around. Unfortunately, nobody is talking about it, because if you increase the consumption, right, it is a problem for everybody, and emission will be more, energy cost will be more, will be dependent on them, their petroleums will be more dependent on them, right. So, therefore, we need to solve this, both the social, for the economical and also the technological solution. That means multi-pronged approach should be adopted for solving this problem, right. So, let me just tell you that global CO2 emissions is if you look at India is 7% of the total, and we are having 130 crore people, So, therefore, it is very less, okay, whereas China is 30%, United States is 15%, right, and European 9%, of course, others are there. That means we are not really polluting that much, okay. But if we will minimize our utilization, then naturally we can solve the problem, and we can be self-sustained also, provided we will move to the agro based energy production and also consumption, right. So, with this I will tell you a lot of work can be done, particularly in the combustion front, provided we understand the fundamental of combustions. And in the next lecture we will be basically starting the thermodynamics of the combustion, or whatever related to the combustion, that thermodynamics we will be discussing in the next lecture. Thank you very much.